Come in 1-6. This is Charlie 4. Do you read me? We've got wounded and we need support. Over.
Hold your fire. Wait for my command.
January 1942. A humid dawn settles over a small Pacific island. The heat presses against the soldiers' helmets, sweat dripping down their necks. Palm fronds sway in the stiff breeze, carrying the distant thrum of artillery across the shoreline. Men squat behind sandbags, scanning the dense undergrowth, eyes sharp, hands gripping rifles. Orders are shouted, but the voices barely carry over the wind, the gunfire, the chaos. In one foxhole, a corporal taps on a bulky field radio. Static hisses in his ears. The signal cuts in and out, a half-formed message barely reaching command. Frustration etches his face. In another position, a squad waits minutes too long for instructions, the enemy moving silently through the jungle. Across the island, an officer jots down missed calls, grimly tallying the risk. Every delay could mean lives lost. Somewhere in Chicago, far from the front line, engineers at Zenith Radio Corporation are hunched over workbenches, soldering wires and testing battery packs. They are racing against time, trying to shrink the world's most critical lifeline into a portable box that could fit on a soldier's back. The war is moving fast, and so must communication. The first portable radios are coming. In early 1942, the United States was grappling with a war it had only recently entered. The attack on Pearl Harbor, less than 2 months earlier, had exposed the nation's unpreparedness for global conflict. The Pacific Theater, in particular, demanded rapid, flexible communication. American forces were scattered across islands and coastlines, facing an enemy that had been waging mobile, coordinated campaigns for years. Yet the U.S. military, despite its industrial might, lacked a critical tool: effective, portable radios for frontline units. Before the war, most military communication relied on large, cumbersome equipment. Field radios were heavy, often requiring teams of men or vehicles to transport them. They depended on fixed power sources or unreliable field batteries that lasted only a few hours. Lines of wired telegraph or telephone could not keep pace with fast-moving operations, especially in jungles, deserts, or newly captured territories. In many cases, soldiers resorted to runners or visual signals, flags, lamps, even drums, methods that were slow and prone to error. By contrast, Axis forces had been developing portable radio sets for years. The German Wehrmacht had the Funkgerät, a backpack radio capable of transmitting across several kilometers. The Japanese military also fielded battery-powered radios for island-to-island coordination. These tools allowed commanders to relay orders quickly, adjust artillery fire, and coordinate movements across dispersed units. For the Americans, the lack of similar technology created a dangerous disadvantage. Units could be isolated, reinforcements delayed, and ambushes left unreported. The U.S. Army and Marine Corps recognized the urgency. In January 1942, reports from Pacific garrisons described delays in communication costing precious minutes and sometimes lives. A Marine captain in the Solomon Islands wrote that messages are fragmented, delayed, and often lost entirely. Men are forced to act without orders, and confusion reigns. Infantry officers, engineers, and Signal Corps personnel all highlighted the same problem. Existing radios were too heavy, too fragile, or entirely absent from frontline units. The technological gap was stark. Civilian radios in 1941 were primarily home entertainment devices, designed for stationary use and power by household electricity. The components, vacuum tubes, transformers, and batteries, were not optimized for portability or harsh environments. Soldiers could not carry these radios into combat. The weight and fragility made them impractical. Batteries drained quickly, tubes shattered under vibration, and signal ranges were inconsistent. The military needed a device that was rugged, lightweight, and self-powered, a portable lifeline capable of reaching command posts miles away. Government agencies quickly turned to American industry for solutions. Among the companies approached, Zenith Radio Corporation stood out. Founded in Chicago in 1918, Zenith had established a reputation for innovation in consumer electronics. By the late 1930s, they were producing high-quality home radios, experimenting with compact designs and improved circuitry. Their engineers were familiar with vacuum tubes and power-efficient designs, knowledge that could be adapted to military needs. In early 1942, the War Department awarded Zenith contracts to develop battery-powered radios suitable for infantry, artillery, and reconnaissance units. However, converting civilian designs into battlefield-ready equipment was no simple task. Engineers faced multiple challenges. Radios had to operate reliably in heat, humidity, rain, and dust. They needed to be lightweight enough to carry in the field, yet capable of transmitting over long distances. Batteries had to last for hours, not minutes, and the units had to withstand the constant jostling of marches, vehicle transport, and combat. Every component required testing, refinement, and approval. Even minor failures could render the radio useless and cost soldiers their lives. The military context heightened the urgency. In the Pacific, small islands like Guadalcanal and Wake were scattered over vast stretches of ocean, with supply lines vulnerable to enemy attack. Delays in communication could allow Japanese forces to infiltrate or reinforce positions unnoticed. In North Africa and Europe, rapidly advancing or retreating units needed constant contact with artillery, air support, and headquarters. Commanders knew that without portable radios, operational flexibility was severely constrained. By mid-1942, the problem was no longer theoretical. Reports from training exercises and early deployments emphasized that the U.S. risked falling behind its enemies, not just in firepower, but in coordination. Military leaders pressed manufacturers like Zenith to accelerate development, reduce weight, and improve battery life. Engineers worked day and night, testing prototypes, redesigning circuits, and experimenting with new materials. The challenge was monumental, but the stakes were clear. Success meant giving American soldiers a fighting chance. Failure could prolong the war and increase casualties. As engineers refined the first battery-powered sets, the outlines of a solution began to take shape. Portable radios would soon replace runners and improvised signals, connecting units in ways previously impossible. The stage was set for a technological breakthrough that would redefine battlefield communication and change the way wars were fought. Zenith Radio Corporation faced a daunting challenge. The company had built its reputation on consumer electronics, home radios, small amplifiers, and entertainment devices. But the War Department now demanded something entirely different. A rugged, portable radio capable of surviving the harshest combat conditions while delivering reliable communication across miles of battlefield terrain. The engineers in Chicago were suddenly at the front lines of innovation, tasked with translating household technology into instruments of war. By early 1942, Zenith had assembled specialized teams of engineers, electricians, and technicians. Workbenches were crowded with vacuum tubes, coil assemblies, and battery cells. Prototypes were stripped down to their essentials, circuits redesigned to conserve power, and housings reinforced to withstand heat, humidity, and impact. Designers experimented with different tube types, seeking a balance between durability and efficiency. Every decision, every gram of weight saved, every milliamp of current conserved, could mean the difference between a functioning radio on the battlefield and a soldier left in isolation. Government oversight added another layer of pressure. The War Department set strict specifications. Radios could not exceed certain dimensions or weight. Batteries had to last for several hours of continuous operation, and transmissions needed to reach at least 5 kilometers in dense terrain. Zenith engineers collaborated closely with the Signal Corps, running simulations and field tests to ensure the sets could survive tropical jungles, North African deserts, and European forests. Feedback was rapid and uncompromising. A single prototype failure could mean months of redesign. Production capacity was also a concern. Zenith had to balance military contracts with civilian demand, which remained high despite wartime, rationing, and material shortages. Aluminum, copper, and other critical materials were tightly controlled, requiring innovative substitutions and efficient manufacturing techniques. Workers labored long hours, often testing hundreds of prototype radios daily, each one undergoing vibration, heat, and humidity trials. The urgency was constant. With every passing week, American soldiers were at risk due to the absence of reliable, portable communication. Meanwhile, intelligence reports from the Pacific highlighted the stakes. U.S. forces on islands like Guadalcanal and the Solomons were often isolated, reliant on runners or signal flags to coordinate attacks and call for artillery support. Units that lacked radios struggled to maintain situational awareness. Commanders repeatedly emphasized that portable communication devices could reduce confusion, prevent friendly fire incidents, and improve morale by ensuring soldiers were connected to command. In this environment, The Zenith engineers' work was not an abstract project. It was a matter of survival. By spring 1942, the first working prototypes began to emerge. They were bulky by modern standards. Some weighed over 30 pounds, but they represented a revolutionary shift. The radios could be carried by a single soldier or mounted on light vehicles. They used newly designed dry cell batteries, eliminating dependence on fixed power sources. Signal ranges were extended through improved circuitry and antenna design. While far from perfect, these early sets demonstrated that portable, reliable communication for frontline troops was now possible. Training exercises followed quickly. Soldiers were taught how to assemble, operate, and maintain the radios under field conditions. Signal officers emphasized proper battery handling, tube replacement, and emergency repairs. The initial deployments highlighted both success and ongoing challenges. Radios occasionally failed under extreme conditions, and weight still limited mobility. Yet, even with these limitations, the presence of a battery-powered radio transformed operations. Platoons could coordinate movements, request artillery support, and transmit intelligence without waiting for runners or risking exposure. The efforts of Zenith and the military marked a turning point in U.S. communication strategy. Where once orders were fragmented and delayed, a network of portable radios promised real-time coordination. Engineers continued refining designs, driven by field feedback and the pressing needs of soldiers. By mid-1942, production ramped up and the first significant numbers of radios were being shipped to the front lines. This marked the beginning of a new era in which American forces would no longer be hampered by communication delays. The technological leap achieved by Zenith set the stage for multiple angles of impact: human, tactical, technological, and strategic. Soldiers would experience the difference firsthand. Commanders would gain flexibility. Engineers would witness the fruits of innovation applied under extreme conditions. And on the battlefield, even a few extra minutes of communication could decide life or death. The development of these portable radios did not merely solve a technical problem. It reshaped the way the U.S. Army and Marine Corps could operate. What had begun as a gap in preparedness became an opportunity for ingenuity, collaboration, and rapid adaptation. The stage was set for a transformation that would ripple across every theater of the war. For soldiers in the field, the arrival of a portable radio was more than a convenience. It was a lifeline. Before battery-powered sets, infantrymen and Marines often relied on runners to carry messages across dangerous terrain, exposing themselves to gunfire, landmines, and the elements. A single misdelivered message could result in missed reinforcements or even friendly fire incidents. The first soldiers trained with Zenith radios quickly realized the psychological impact. Confidence in one's own position and communication became as vital as physical readiness. A Marine in the Solomon Islands recalled later that hearing the clear, crackling voice of a headquarters operator over a portable set brought a sense of reassurance, a reminder that command was aware and help was possible. Radios reduced confusion, allowed soldiers to coordinate more effectively, and, crucially, saved lives. From a tactical perspective, portable radios changed the speed and accuracy of battlefield coordination. Units could relay positions, adjust artillery fire, and request air support almost in real time. In jungle warfare, where visibility was limited and traditional signaling often failed. These radios allowed for synchronized maneuvers that were previously impossible. Platoon leaders could now call in reinforcements during an ambush, reposition artillery batteries based on frontline reports, and adapt rapidly to enemy movements. In effect, portable radios extended command authority directly into the hands of soldiers on the front line, making units more agile and responsive. The radio became both a tactical instrument and a force multiplier, reshaping operational doctrine in months rather than years. The engineering innovations behind Zenith's radios were revolutionary for their time. Early sets utilized compact vacuum tubes, lightweight chassis, and newly designed dry cell batteries that could withstand heat and humidity. Antenna systems were redesigned for portability and signal clarity, balancing range with soldier mobility. Engineers also experimented with modular components, allowing quick field repairs, an essential feature in combat zones where replacement parts were scarce. Each advancement, from battery efficiency to shock-resistant casings, represented meticulous problem-solving under extreme constraints. These radios were not merely smaller versions of home devices. They were purpose-built tools designed to survive the unpredictability of war. The ingenuity displayed by Zenith engineers would influence military communications for decades, setting new standards for durability, portability, and reliability. These three angles, human, tactical, and technological, demonstrate the immediate impact of battery-powered radios on frontline operations. Soldiers felt safer, units operated with greater precision, and engineers proved that civilian innovation could meet the demands of modern warfare. This section naturally leads to the next angles, which will explore leadership, enemy reactions, and moral considerations, the broader implications of introducing portable radios into the battlefield. For commanders, the arrival of portable radios transformed the way battles could be planned and executed. Generals and field officers who had previously depended on delayed reports could now receive timely intelligence from multiple units simultaneously. This allowed for more dynamic decision-making, faster responses to enemy maneuvers, and greater coordination across dispersed forces. A battalion commander in the Pacific Theater noted that for the first time, he could adjust troop positions in real time, calling artillery strikes or air support precisely when needed. Radios allowed leaders to extend their reach across rugged terrain, connecting headquarters with forward units in a way that was previously impossible. The presence of portable communication tools gave officers both confidence and flexibility, changing the very calculus of strategy. The introduction of portable radios did not go unnoticed by the Axis powers. Japanese and German forces quickly recognized the improved coordination they brought to American units. In the Pacific, Japanese commanders observed that U.S. troops were responding faster, moving more cohesively and coordinating attacks with greater precision. This forced the enemy to adapt. Interception of radio signals became a focus, and countermeasures, including signal jamming and the use of deceptive transmissions, were employed. The radios altered the battlefield in subtle ways, forcing adversaries to reconsider ambushes, reinforcements, and timing. Where once U.S. units struggled to act in unison, they now presented a more coordinated and difficult target. portable radios had become not just a tool for communication, but a factor shaping enemy strategy. Beyond tactical and strategic considerations, portable radios had a profound moral impact on the troops. Soldiers who were previously isolated, cut off from command, or unsure of reinforcements now felt a renewed sense of connection and security. This psychological advantage bolstered morale, reduced panic during ambushes, and gave soldiers the confidence to take initiative without fear of miscommunication. Communication failures had previously led to tragic errors. Friendly fire incidents, unnecessary exposure to enemy positions, and missed rescue opportunities. The radios did not eliminate danger, but they mitigated it, providing a tool that could preserve life and allow soldiers to operate with greater assurance. In essence, portable radios humanized the battlefield by restoring the vital link between command and those facing the fight directly. Another critical angle was the necessity of training. Soldiers and Signal Corps personnel had to learn how to operate, maintain, and repair these new devices under extreme conditions. Improper handling could render a radio useless at a critical moment. Intensive drills taught soldiers how to change batteries quickly, replace tubes, and establish secure communications lines while under fire. Training also emphasized operational discipline, keeping transmissions brief, clear, and coded to prevent enemy interception. The introduction of portable radios, therefore, did not merely supply technology. It demanded a cultural shift in how troops thought about communication, coordination, and battlefield responsibility. Portable radios also enhanced joint operations across branches of the military. Infantry, artillery, and air support could now coordinate seamlessly, linking movements across land, sea, and air. For the first time, multi-branch operations could rely on a relatively instantaneous communication network, making combined attacks more precise and reducing delays that had previously hampered complex maneuvers. This integration highlighted the radio's broader strategic significance, demonstrating that communication technology could shape not just individual skirmishes, but entire campaigns. By mid-1942, the first Zenith battery-powered portable radios had reached the front lines. In the Pacific, U.S. Marines stationed on islands such as Guadalcanal and Tulagi were among the earliest to receive the new equipment. These radios, though still heavy and imperfect by modern standards, represented a seismic shift in battlefield capability. For the first time, frontline units could maintain near-instant communication with headquarters, artillery units, and neighboring platoons. Commanders who had previously relied on runners and signal flags could now issue real-time orders. The first combat test of the radios occurred during early skirmishes on Guadalcanal in August 1942. Japanese forces were entrenched in dense jungle, executing flanking maneuvers that had previously caught U.S. troops off guard. In one engagement, a Marine company under Captain James Gallagher found itself isolated on a ridge, cut off from supporting units. Using a Zenith portable radio, Gallagher transmitted precise coordinates to an artillery battery 3 kilometers away. Within minutes, supporting fire arrived, halting the enemy advance and allowing the company to regroup. Soldiers who had spent months struggling with unreliable communications now experienced the immediate impact of battery-powered connectivity. Simultaneously, in the Aleutian Islands, U.S. Army units conducting reconnaissance against Japanese positions tested the radios under harsh conditions: sub-zero temperatures, high winds, and constant precipitation. Early prototypes had occasionally failed under such stress, but the improved casings, shock-resistant chassis, and efficient batteries ensured reliability. One Army lieutenant later recounted that the radio was like a lifeline through the storm. Every report we sent was received. Every order we received was clear. It was the first time we truly felt in command of our operation. The impact of the radios extended beyond isolated battles. Coordinated attacks became more feasible, and units could adapt to enemy movements dynamically. Forward observers relayed artillery adjustments in real time. Infantry units repositioned based on immediate intelligence, and medical teams could request evacuation without delay. Each successful transmission reinforced trust in the technology, building a network of confidence that extended across entire theaters of operation. Yet deployment was not without challenges. Soldiers had to balance mobility with the need to protect their radios. The sets, while portable, still weighed between 25 and 30 pounds, requiring careful planning for movement across rough terrain. Antennas had to be extended fully to achieve maximum range, making operators vulnerable to enemy observation. Batteries were finite, and overuse could render the equipment useless in critical moments. Despite these limitations, the radios proved transformative, turning previously vulnerable units into coordinated, self-sufficient forces. The first large-scale operation demonstrating the strategic value of portable radios occurred during the Battle of Midway, June 1942, although on naval platforms rather than jungle combat. Although primarily a naval engagement, shore-based reconnaissance units and small landing parties relied heavily on portable sets to transmit intelligence on enemy ship movements. Information flowed faster than ever before, allowing commanders to adjust fleet positions with unprecedented speed. The radios shortened the decision-making cycle, illustrating how communication technology could influence outcomes not just in isolated skirmishes, but in decisive battles. The human element remained central. Soldiers who had once feared isolation now felt empowered. Corporals and sergeants were suddenly conduits of strategy, carrying the ability to connect men in the field directly to senior officers. Each successful transmission was not merely a technical victory. It was a moment of reassurance, a lifeline in the chaos of combat. Reports from the front frequently highlighted the morale boost that radios provided. A lieutenant in the Solomons described it simply: "We knew someone was listening, someone could help." That made all the difference. The first months of deployment also provided engineers with invaluable feedback. Field reports revealed minor flaws: tubes that overheated in tropical sun, connectors that loosened under vibration, and antennas prone to breakage. Zenith engineers responded swiftly, iterating designs and sending improved units to the front lines. The rapid cycle of testing, deployment, and refinement illustrated a rare synergy between industrial ingenuity and military necessity. By late 1942, the combination of battlefield necessity, human reliance, and engineering innovation reached a tipping point. Portable radios were no longer experimental tools. They were indispensable instruments of war. Commanders began integrating them into planning at every level. Soldiers relied on them instinctively, and enemy forces had to contend with a more coordinated, responsive adversary. The stage was now set for dramatic demonstrations of the radio's full potential. The next phase would show how these devices directly shaped the outcomes of battles, turning marginal engagements into strategic successes and fundamentally altering the conduct of modern warfare. The true test of Zenith's portable radios came during the fall of 1942 as American forces expanded operations across the Pacific and prepared for campaigns in the Solomon Islands and New Guinea. By this time, multiple infantry and marine units were equipped with the battery-powered sets, and officers had integrated them into daily tactical planning. For the first time, forward positions could maintain a near-constant link with command, allowing for rapid adjustments to enemy movements, coordinated artillery strikes, and timely medical evacuations. One defining moment occurred during the Battle of Guadalcanal in October 1942. A U.S. Marine patrol, tasked with securing a strategic ridge overlooking an enemy supply route, became pinned down under heavy fire. Previous attempts to coordinate reinforcements would have relied on runners navigating open ground or signal flags visible only for short distances. Instead, the patrol's corporal operated a Zenith portable radio, transmitting exact coordinates to artillery batteries positioned 2 kilometers away. Within minutes, a precise bombardment forced the enemy to retreat, allowing the patrol to advance and secure the ridge with minimal casualties. Soldiers described the event as a revolution in how we fought. Suddenly, we weren't alone on the battlefield. Elsewhere, during reconnaissance operations in New Guinea, radio communication enabled multiple units to synchronize attacks against entrenched Japanese positions. Patrols transmitted intelligence on enemy numbers, fortifications, and movements, allowing higher command to deploy reinforcements at critical moments. For the first time, small American units could act with the confidence that their actions were coordinated with a larger operational plan. The radios did not merely provide information. They actively shaped the unfolding battle. Naval engagements also demonstrated the transformative power of portable radios. Small landing parties and coastal observation units relied on Zenith sets to report Japanese ship movements and artillery placements. At the Battle of Cape Esperance in October 1942, timely transmissions from forward observation posts alerted the U.S. Navy to an approaching Japanese task force. The fleet adjusted course and deployed ships for optimal engagement, contributing directly to a decisive victory. The portable radios were no longer optional. They had become mission critical. Field reports emphasized not only tactical success, but also human impact. Soldiers wrote of the psychological reassurance provided by a functioning radio, the knowledge that command was listening, that reinforcements could arrive, and that the broader operational picture was within reach. In letters home, Marines in the Solomons described carrying the radios as both a responsibility and a source of pride, an acknowledgement that technology could safeguard lives in the most dangerous environments. The radios also revealed weaknesses in enemy strategies. Japanese forces had previously exploited American communication delays to outmaneuver isolated units. With the introduction of portable radios, those vulnerabilities diminished. The Axis command began deploying countermeasures, signal jamming, deceptive transmissions, and patrols to locate and destroy radios. But the speed and flexibility of American units often outpaced these efforts. On multiple occasions, Japanese troops reported confusion over coordinated U.S. advances, a disruption directly linked to the newfound ability of frontline units to communicate seamlessly. From a production perspective, Zenith continued to refine designs based on combat experience. Engineers received detailed field feedback, batteries that overheated in the tropics, antenna failures under stress, and occasional tube burnout. Each flaw prompted rapid iteration, leading to lighter casings, more efficient power cells, and reinforced antennas. The cycle of deployment, feedback, and improvement accelerated innovation, allowing subsequent waves of radios to be more reliable, lighter, and easier to operate under combat conditions. By late 1942, over 1,000 portable sets had been distributed across the Pacific, North Africa, and training units preparing for operations in Europe. The cumulative effect of these radios on battlefield operations was undeniable. Units moved faster, coordinated more effectively, and responded to unexpected developments with agility. The technology amplified both leadership and human capability. Commanders could execute complex maneuvers with precision, and soldiers could trust that their actions were aligned with broader strategy. For the first time, portable, battery-powered communication became a decisive factor in shaping tactical and strategic outcomes. By the end of 1942, the introduction of Zenith portable radios marked a clear turning point in U.S. military operations. Where once delays in communication had slowed advances and cost lives, instantaneous, reliable transmission enabled coordinated, flexible, and confident action. The radios had transformed the battlefield, proving that innovation and industrial ingenuity could directly influence the course of a war. By early 1943, the impact of Zenith's battery-powered portable radios was becoming unmistakably clear across multiple theaters of war. Units that had previously struggled with delayed communications now operated with far greater efficiency and coordination. Commanders reported fewer instances of friendly fire incidents, faster reinforcement of isolated positions, and more precise artillery support. In the Pacific, the difference was tangible. Patrols and reconnaissance teams could relay intelligence about enemy positions in real time, enabling tactical adjustments that had previously been impossible. Production of the radios had ramped up considerably. Zenith, in collaboration with the War Department, expanded factory output, standardizing components to streamline assembly. Thousands of sets were shipped to forward areas, including the Solomon Islands, New Guinea, and Alaska. Military supply chains adapted to include batteries, spare tubes, and repair kits, ensuring that radios could be maintained in the field. the widespread deployment marked a turning point. Portable radios were no longer experimental tools. They were essential military equipment. The human consequences were equally significant. Soldiers and officers alike described increased confidence and morale. Reports from Marines in the Solomons highlighted how units, previously cut off from command for hours or days, now felt connected to the larger battle, reducing panic and enhancing combat effectiveness. Letters from the front frequently mentioned the reassurance that came from having a reliable line to headquarters, a lifeline that could summon help, coordinate attacks, or provide guidance under fire. Strategically, the radios allowed commanders to implement more complex operations. Multi-unit maneuvers, coordinated assaults, and rapid repositioning became feasible on a scale previously unattainable. In North Africa, American forces used portable radios to synchronize infantry and artillery advances during desert campaigns, adapting quickly to German counterattacks. The ability to transmit real-time intelligence and orders transformed planning and execution, giving U.S. forces a tactical edge even against entrenched or numerically superior opponents. Casualty figures began to reflect the radio's indirect effect. Units equipped with portable sets experienced fewer unnecessary losses due to miscommunication or delayed orders. Reports from a signal corps noted that while radios could not eliminate combat risks, they reduced exposure to hazards caused by confusion, isolation, or miscoordination. Soldiers could call for evacuation, request covering fire, and coordinate movements with nearby units, actions that directly impacted survival rates. The impact extended beyond individual battles. Allied forces started integrating portable radios into training programs and operational doctrine. Lessons learned from the Pacific, New Guinea, and North Africa informed strategies for upcoming campaigns in Italy, France, and the broader European theater. Communication reliability became a core principle in operational planning, with portable radios at the center of a shift toward faster, more flexible, and better coordinated warfare. The production and distribution of these radios also illustrated the collaboration between American industry and the military. Zenith's engineers continued to refine designs based on frontline feedback, while military logisticians ensured that radios, batteries, and repair tools were available where needed. This ongoing cycle of innovation and deployment created a feedback loop. Better radios improved battlefield outcomes, which provided more data to enhance future iterations. By late 1943, portable radios had become a ubiquitous part of American military operations, their influence extending from small unit engagements to large-scale strategic campaigns. The stage was now set to examine the broader, long-term consequences. Beyond immediate battlefield success, portable radios reshaped military strategy, industrial collaboration, and the very nature of communication and combat. By mid-1943, the full strategic significance of portable battery-powered radios became evident. Beyond improving individual unit coordination, the radios reshaped entire campaigns. Infantry, artillery, and air support could operate in near real time, with frontline intelligence immediately reaching higher command. Commanders no longer had to rely on slow couriers or intermittent wired connections. The ability to transmit and receive information rapidly allowed for more flexible operational planning and faster responses to shifting battle conditions. In the Pacific theater, this technological advantage proved decisive during the continued island-hopping campaign. At Cape Gloucester and Bougainville, small American units, often operating in isolated terrain, used portable radios to relay intelligence on enemy positions, adjust artillery fire, and coordinate supply drops. Reports highlighted that previously unmanageable coordination challenges were now being addressed with remarkable efficiency. Units moved with precision, attacks were synchronized, and reinforcement or evacuation requests were executed without delay. These improvements not only reduced casualties, but also accelerated the tempo of operations, giving U.S. forces a sustained advantage over Japanese defenders. Production numbers soared. Zenith, supported by government contracts and material prioritization, manufactured tens of thousands of portable radios by late 1943. The company continued refining the devices, improving battery life, reinforcing casings, and making components more field serviceable. This expansion ensured that nearly every infantry and artillery unit could be equipped with a portable set, standardizing communication protocols across diverse theaters of operation. Engineers also adapted designs for specialized applications. Amphibious landings, reconnaissance patrols, and armored units all received variants suited to their unique requirements. The influence of portable radios extended beyond immediate tactical outcomes. The U.S. Army and Marine Corps began incorporating them into doctrine, training programs, and strategic planning. Signal Corps units were trained not only in operation and maintenance, but also in encryption and secure communication procedures. The radios became central to operational strategy, bridging the gap between technological innovation and battlefield execution. Military planners recognized that communication efficiency could determine the outcome of entire campaigns, making portable radios as vital as tanks, aircraft, or artillery. Zenith's contribution also set a precedent for military-industrial collaboration. The rapid development, testing, and deployment of these radios demonstrated how civilian engineering expertise could be harnessed to meet urgent military needs. Field feedback from soldiers directly influenced subsequent design iterations, creating a dynamic cycle of innovation that accelerated technological adaptation. The success of Zenith's battery-powered radios became a model for future military projects, where speed, reliability, and iterative improvement could directly influence combat effectiveness. The psychological and moral impact on soldiers remained profound. Reports from combat units consistently described the reassurance provided by reliable communication. Troops felt less isolated, more confident, and more connected to the broader strategy of the war effort. Friendly fire incidents and operational confusion declined, and soldiers could make informed decisions in high-stress scenarios. In essence, the radios enhanced both the effectiveness and the humanity of warfare, providing a lifeline in the chaos of battle. By the end of 1943, portable battery-powered radios were no longer a novelty. They had become indispensable tools of modern warfare. The combination of industrial innovation, tactical necessity, and human reliance created a lasting legacy. Units equipped with these radios operated more efficiently, commanders planned with greater confidence, and the U.S. military gained a technological edge that reverberated across the Pacific, European, and North African theaters. The stage was now set for reflection. The story of Zenith's radios was more than a tale of engineering triumph. It was a narrative about adaptation, human resilience, and the way technology can alter the course of history. The story of Zenith's battery-powered portable radios is, at its core, a story of human ingenuity meeting necessity. Faced with a world at war, engineers in a Chicago factory transformed consumer electronics into instruments that could save lives, shape battles, and redefine strategy. On distant islands, in dense jungles, and across oceans, soldiers carried these devices as lifelines, bridging the gap between isolation and command, chaos and coordination. The radio's impact extended beyond technology. They changed how soldiers perceive the battlefield. Men who had once felt abandoned by distance and disorder now operated with confidence, knowing their voices could reach artillery units, headquarters, or fellow squads. Leadership became more dynamic, allowing commanders to respond in real time to the ever-shifting patterns of combat. Even the enemy had to adjust, recognizing that American units were no longer fragmented, but interconnected, adaptive, and resilient. Strategically, the introduction of portable communication marked a turning point in modern warfare. It demonstrated that technological innovation could amplify human capability, not just in firepower, but in coordination, morale, and survival. The lessons learned: rapid adaptation, close collaboration between engineers and military planners, and iterative refinement based on field feedback, set precedents for future conflicts and peacetime innovations alike. In the broader sweep of history, Zenith's radios remind us that war is not only fought with weapons, but with ideas. A lifeline, a spark of ingenuity, a few ounces of carefully designed circuitry. These small interventions can reverberate across campaigns, saving lives and tipping the balance of strategy. For every soldier who pressed a button, transmitted a message, or waited anxiously for a reply, the portable radio became more than a machine. It became a symbol of connection, resilience, and hope. In the end, the challenge of 1942, the absence of portable radios, was met not with improvisation alone, but with deliberate innovation. And in solving that challenge, humanity took another step toward mastering the art of communication in war, leaving a legacy that would shape every battlefield to come.